Alright everybody, in this video what we're going to do is we're going to do 4 of these problems. We are going to use the angle addition identities. Something that'll be very useful for you is to have that reference chart, and that's what I'm going to be using. So I'm going to go and pull that up here in just a second. So here's the reference chart that I'm referring to. I assigned it to you guys that allow us to be able to work through these problems. We're going to be using this one right here, the tangent of theta plus phi, except I'm going to use x and y instead of theta and phi. It's a little bit easier. So let's go ahead and write this problem down. It's one second. Here we go. It says we're going to find the tangent of 19 pi over 12, exactly using angle addition or subtraction formulas. So what I'd like you to do is just write down the tangent of 19 pi over 12. Now, there's lots of ways to do this. For me, the way my brain works, I typically work better in degrees than I do radians. This is in radians, so I want to convert it to degrees. So how do we convert 19 pi over 12 into degrees? All you got to do is just multiply it by 180 over pi. And when you multiply 19 pi over 12, and multiply by 180 over pi, what you're going to get is you're going to get 285 degrees. Alright? And that's going to allow me to use the formula a little bit easier because I can break down this number a lot easier than breaking down the 19 pi over 12. So write down 285 degrees. And what we're going to do is I want you to draw a couple of unit circles with me. And we'll explain to you how to use the formula using this concept of the unit circle. Alright, so I've drawn a couple of unit circles. Right now what I'd like to do is go back to my reference, take a screenshot of this, and the one we're going to use right here is we're going to use this one right here. So in your journal, what I'd like you to do is I'd like you to change this theta, that's spelled T-H-E-T-A, and this is spelled P-H-I, that's 5. We're going to change it to x and y. So I'm going to rewrite this as we're going to find the tangent of x, meaning the measure of the angle, plus the tangent of y all over 1 minus the tangent of x times the tangent of y. So that's what I'm going to be using, and x and y just mean the measure of our angles. So let me head back over here. Now, probably the easiest way, there's lots of ways to break this 285 degrees down, but when I thought about breaking it down, I was like, well, I know I can take 60 degrees and I can add 225 degrees. My suggestion is always try to find a 30-degree angle, a 60-degree angle, or a 45-degree angle, because the 30-60-90 and the 45-45-90 triangles are going to be the easiest to find the sine, the cosine, and the tangent. So we're going to use 60 plus 225. I'm going to call this x. I'm going to call this y. So here's how I'm going to set it up. Okay, I'm going to call this the tangent of x plus y equals the tangent of x plus the tangent of y all over 1 minus the tangent of x and the tangent of y. So let's go ahead and just kind of substitute our numbers. Tangent of, we're going to put 60 degrees plus 225 degrees. So what I'm going to find is I'm going to find the tangent of 60. I'm also going to find the tangent of 225. I'm going to divide that by 1 minus the tangent of 60 and the tangent of 225. Now I'm going to use the unit circle. We're going to find the tangent of 60. So right now, let's call this about a 60-degree angle. So I'm making a right triangle right here. there's my 60 degrees. All right, and the 30, 60, 90, this side, we could call this side 2, this side 1, this side radical 3. All right. I'm going to go ahead and write the 30, 60, 90 ratios. I'll erase this right here. (30, 60, 90, x radical 3, 2x. Alright, so in a 30, 60, 90 triangle, if I were just to build one right here, alright, call that 60, call this 30, call this 90. Across from the 30-degree side, that's a 1. Across from the 60-degree side, we'll call it radical 3. And then the hypotenuse is 2. That's where I got the radical 3, the 1, and the 2, using the 30, 60, 90. Okay. So this is an example for our 60 degree. Now we're going to use an example for a 225 degree. Okay, so let's go ahead and travel with me right here. This is our initial side. So now we're going to travel 90 degrees. Oops. All right, 180, and an additional 45 degrees puts us right here. So from here going all the way to there is 225 degrees, and that actually makes a 45, 45, 90 triangle. So it's not a perfect one, but hopefully you can see how this would be a 45, 45, 90 right in here. And here in the third quadrant, we know the x value is negative, and we know the y value is negative. All right? So in a 45, 45, 90, here are some common numbers that you can use for 45, 45, 90. We call it a 1 and a 1 and a radical 2. All right? So we could say 1 and radical 2. So we could say this is negative 1 and this is negative 1. So our order pairs would be negative 1 over negative 1. And then we could say this side is radical 2. Now, interestingly enough, tangent of any angle is always the y value in comparison to the x value. Well, our y value over our x value ends up becoming negative 1 over negative 1, and that just becomes a 1. So the tangent of 225 degrees equals 1. So we're going to use that. So what would the tangent of 60 degrees equal? All right? If we have the y value over the x value. Well, also known as the opposite over the hypotenuse. All right, so here we go. Our x value is a 1. Our y value is radical 3, that point right there. There's our x, there's our y. So the tangent of 60 ends up becoming just radical 3. So we're going to, anytime we see tangent of 60, we're going to put in a radical 3. Anytime we see tangent of 225, we're going to put the number 1. All right, so we'll go down here, and we're going to go and start substituting some things in. All right, so here we go. Right now, I have the tangent of 60 degrees, and I know that's radical 3. And then right here, I have plus the tangent of 225. I know that's going to be 1 over 1 minus the tangent of 60 degrees, which is radical 3, times the tangent of 225, which is 1. So here's what I end up having. And I'm going to go and put the real number up front and the irrational number in the back, because that's how we like to do it. All the real numbers up front, all the rationals up front, irrationals in the back. And then over here we have 1 minus radical 3. Now what we're going to do is we are going to multiply 1 minus radical 3 by what's called its conjugate. All right, so we're like, what the heck is that? So here's what that's going to look like. We're going to call this 1 plus radical 3 and 1 plus radical 3. And then we're going to go ahead and do the FOIL method, and we'll show you how that works out. It's quite easy. Now, you know what? I'm going to check real quick before I do all this. I'm going to check real quick to see if this is possibly one of the answer choices. So let me take a quick look. Oh, looks like they actually have it right here. That's one of the answer choices. Looks like 1 plus radical 3, 1 minus radical 3. All right, so I guess you don't have to simplify it, but you know what? I'm going to go ahead and simplify it. All right, so here we go. I'm going to show you how to multiply 1 minus radical 3 times 1 plus radical 3. So we get 1 times 1, which is 1. 1 times positive radical 3, which is positive radical 3. Negative radical 3 times 1, which is a negative radical 3. And a negative radical 3 times a positive radical 3 ends up becoming just negative radical 9, but that becomes a minus 3, because the square root of 9 is 3. So I'm just going to erase that and just put 1 and a minus 3. Like, what the heck did you just do? Negative radical 3 times a positive radical 3 becomes a negative radical 9, but the square root of 9 is just 3. So that's how I got that, minus 3. Add them all together, you get, that zeroes out, and you get 1 minus 3, which becomes a negative 2. Okay. Up here, we're going to multiply these two binomials. This is just a sum of squares. It's very easy to multiply together. Won't take long at all. And here we go. 1 times 1 is 1. 1 times radical 3 is a radical 3. Another radical 3 times 1 is another radical 3. And radical 3 times radical 3 is just 3. 1 plus 3 gives us 4. Radical 3 plus radical 3 becomes 2 radical 3, all over a minus 2. But that goes into both numbers, and so you're left with negative 2 minus radical 3. And interestingly enough, that actually is the simplified answer, which they didn't make you actually get to. Okay, so real quick, I'm going to show you so you can understand this is the exact same answer. If I made a fraction and I typed in 1 plus radical 3, okay, and underneath it I put 1 minus radical 3, you get this decimal right here. But the simplified answer, which actually would be the best answer, and if I was having to take a standardized math test or math certification test, they wouldn't list this. They would actually list this answer. And you'll see how these actually are the same number, but this is actually a better simplified form than this. But fortunately for you, there's the answer right there. All right, here's our next question. We're going to find the sine of 5 pi over 12. Now, once again, what I like to do is I like to change 5 pi over 12, which is in radians. We're going to change it to degrees. So I'm just going to go ahead and do 5 pi over 12. I'm going to multiply it by 180 over pi to convert it to degrees. And when you do that, you get 75 degrees. Now, how do we split this 75 degrees? We're going to use the angle addition or subtraction formula. This time we're going to use the addition formula once again, and what I like to do is I like to break 75 down into 45 degrees plus 30 degrees, because that allows me to use my 30, 60, 90 triangles. Okay? So we are going to use the sine of x plus y. And the formula for the sine of x plus y, if I go back a couple, nope, sorry, wrong one. Here we go. So we're going to use this formula right here. Okay, except I'm going to use x and y instead of theta and phi. So the sine of x and the cosine of y. So I'm going to write sine of x and the cosine of y plus the cosine of x times the sine of y. Now this time I'm actually going to use 45 degrees and 30 degrees. So I'm going to break it down into 45 degrees plus 30 degrees. So here we go. We're going to find the sine of 45, and we're going to multiply it by the cosine of 30. Then we're going to take the cosine of 45, multiply it by the sine of 30. Okay, so to make it easy, let's go ahead and build our 30, 60, 90. I already know the sine of 45, the cosine of 45, and all the other ones, but you guys are just kind of learning along with me, so we're going to make a nice 45, 45, 90 triangle. We're going to make a nice 30, 60, 90. So here we go. 45 degrees, 45 degrees. We're going to call this the 60-degree angle, call this the 30-degree angle. We'll call this 1, 1, radical 2, and we are going to call this 1, radical 3, and 2. Now, to make it a little bit easier for us, what I'm going to do is I'm going to change this to radical 2 over 2, radical 2 over 2, and 1. Okay? This is basically what it's going to simplify to, so I'm kind of saving us a step. So, if I said, what is the sine of 45 degrees? That's the opposite over the hypotenuse. The sine of 45 degrees will always be radical 2 over 2. And the cosine of 45 degrees will always be radical 2 over 2. That's the adjacent over the hypotenuse. Okay? So if we wanted to find the cosine of 30 degrees, the cosine is the adjacent over the hypotenuse, so that becomes radical 3 over 2. And the sine of 30 degrees becomes the opposite over the hypotenuse, which is 1 over 2. Now, I'm going to go ahead and label things out, and then we'll kind of go over them one more time. From the 45-degree angle, there's the 45, and then from the 30-degree angle, right there. So once again, this is our opposite side, this is our adjacent side, and this is our hypotenuse. Here's my opposite, here's my adjacent, and here's my hypotenuse. So, when it said the sine of 45 degrees, I was like radical 2 over 2 over 1, which is radical 2 over 2. Cosine of 30 is radical 3 over 2. And then we just put the plus sign right here. Cosine is radical 2 over 2, and the sine is the opposite over the hypotenuse, so it's 1/2. So what is our final answer going to be? Well, radical 2 times radical 3 becomes a radical 6, and 2 times 2 is 4, plus radical 2 times 1 is radical 2, and 2 times 2 is also 4. We have a common denominator right here, so I can simplify that to radical 6 plus radical 2 all over 4, and that's going to be my final answer. I think in the Khan Academy they have it listed as radical 2 plus radical 6 over 4, but these are the same answer essentially. It really doesn't matter which one you lead out with. So I'm going to go over here, and I am going to select answer choice B. Alright, 2 down, 2 to go. Alright, so here we go. The sine of pi over 12. Once again, we're going to go ahead and put pi over 12. We're going to change it to degrees. We're going to put 180 over pi. And that's going to end up becoming 180 divided by 12, which is 15 degrees. So this is actually not going to take us that much time, because I can get to 15 degrees by taking 45 degrees and taking away 30 degrees. So that's going to really help us out here, because we're still going to use the same formula, except what I'm going to do is I'm just going to use the sine, because I think it asks for sine. Yep, sine. So we're going to use the subtraction formula this time. So we're going to use, oh, wrong thing. All right, we're going to use this one right there. All right, which is very similar. It's just there's just going to be a minus sign instead of a plus sign. Cool. So let's go ahead and build everything right over here. We're going to say the sine of x minus y ends up becoming, let's go back and take a look, the sine of x and the cosine of y. Okay, let's write it down. The sine of x and the cosine of y minus the cosine of x and the sine of y. Now this time what we're going to do is we're going to substitute 45 degrees minus 30 degrees. So let's go ahead and substitute now. This won't take long. We already know the answers to these because we just did a problem that dealt with the 45 and the 30 degrees, so we're just going to plug them in. Oops, my bad. Alright, so what was the sine of 45? Well, if we go back, sine 45 was radical 2 over 2. So just use the same ratio. What was the cosine of 30 degrees? The cosine of 30 degrees was radical 3 over 2. What was the cosine of 45? Once again, it was radical 2 over 2. And what was the sine of 30? 1 over 2. So when we do this, we get radical 6 over 4 minus radical 2 over 4, which becomes radical 6 minus radical 2 all over 4. So here's the cool news. Like once you kind of get what the sine of 45 is and the cosine of 30 and the cosine of 45 and the sine of 30, once you get those, you can just have those and plug them into your next problem whenever you need to. So here we go. I'm going to choose answer choice C. That didn't take too long. Not too bad. All right, one more. This one looks like we're taking what? The tangent of 75 degrees. Well, 75 degrees, nothing easier than 75 degrees because 75 degrees can break down into 45 degrees and 30 degrees. So I'm going to take the formula, see here, we're going to take this formula right here. We're going to use it one more time, except we're going to put a 45 and a 30. So I'm going to go ahead and rewrite the formula just for us. So I'm going to say right here, the tangent of x plus y equals the tangent of x plus the tangent of y all over, look real quick, all over 1 minus the tangent of x, tangent of y. Okay. All over 1 minus the tangent of x and the tangent of y. So now all I'm going to do is I'm going to substitute. So here we go. This will be our final problem. So we're going to go ahead and do 45 degrees. We're going to do 30 degrees. We're just going to use our formula, plug it in. So we're going to find the tangent of 45 degrees. We're going to add the tangent of 30 degrees. And we're going to do 1 minus the tangent of 45 degrees times the tangent of 30 degrees. So I'm going to go ahead and build the 30, 60, 90 and the 45, 45, 90 one more time so you guys can see. There. There's the 45, 45, 90. Here's a 30, 60, 90. Try to make it as nice and neat as possible. 45, 45, 90. There's the 60. There's the 30. There's the 90. So we're going to go from this angle right here. I'm going to put a little arrow going across, label it the opposite side. Here's our hypotenuse, and here's the adjacent side. Here's our 30-degree angle right here. I'll label this as our opposite side. Here's our adjacent side, and here's our hypotenuse. So right here, I'm going to go ahead and do 1, 1, radical 2, and here I'm going to do a 1, a radical 3, and a 2. Okay? So 45, 45, 90, x, 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 radical 2. So that's why I did the 1, and the radical 2. And right over here, the 30, 60, 90. Where I did x, x, radical 3, 2x. You've seen this many, many times. 1, radical 3, and 2. Alright, so once again, if you guys remember TOA. Tangent is TOA, which is the opposite over the adjacent. So if I said, what is the tangent of 45 degrees? The tangent of 45 is the opposite over the adjacent. So that's basically just 1 over 1. So the tangent of 45 is 1. So that's what I'm going to use. Okay? What is the tangent of 30 degrees? Well, once again, it's the opposite over the adjacent. Well, the opposite over the adjacent in this particular case is 1 over radical 3. So I'm going to rationalize the denominator by multiplying it by radical 3 over radical 3, and you get radical 3 over 3. So that right there is going to be the tangent of 30. Okay? So here we go. Right here where it says the tangent of 45, I am going to put the number 1. Where it says the tangent of 30 degrees, I'm going to put plus radical 3 over 3. Over. I got to do some erasing here. Hopefully you can go back and write it down if you need to. Over here I have 1 minus the tangent of 45 degrees. And once again, the tangent is opposite over adjacent. That's 1. And over here it says times the tangent of 30, and the tangent of 30 was radical 3 over 3. So now what we have to do is we actually have to simplify this bad mama jamma. Okay? So whenever you're adding fractions, we're going to do the numerator and we're going to do the denominator, and we're going to get it all nice and neat. Okay? So here we go. Here's our numerator. 1 plus radical 3 over 3. So how do we add those together? All right? Well, 1 can be actually rewritten as 3 over 3. Now we have the same denominator. So this becomes 3 plus radical 3 over 3. So there we go. That's what we're going to have. That's right there. There's our numerator. Now I'm going to go and take a look at our denominator right here. I'm going to highlight that in red. And I'll get everything nice and simplified for us. Okay. So here we go. In red. My hand's starting to get tired from writing on this board. Here we go. 1 minus a radical 3 over 3. Well, how do I do 1 minus a radical 3 over 3? Got to do 3 over 3 minus a radical 3 over 3, which becomes 3 minus radical 3 over 3. So that is in the denominator. Okay, so here we go. Here's our numerator. 3 plus radical 3 over 3. All divided by our denominator, which is 3 minus radical 3 over 3. Now that's not totally simplified. We just have to do one little final step. Now it's going to be kind of easy. If you notice there's a 3 in the denominator here and there's a 3 in the denominator here, hopefully you realize you can just cancel those out. But if you didn't know that you could just cancel those out, then I'm just going to go over the process. You'd have to multiply both the numerator and the denominator by the reciprocal. And look what happens when you multiply the numerator and the denominator by the reciprocal. Hopefully you notice that these threes cancel each other out. This cancels this, this cancels this, because those are common factors. And so basically all we're left with is a 3 plus a radical 3 up here in the numerator, and a 3 minus a radical 3 in the denominator. And I have a sneaky suspicion that's going to be one of the answer choices, but let's just see if it is or not. Okay? 3 plus radical 3 over 3 minus radical 3, answer choice B. But we can also even go one step further. If you don't want to watch this step, I totally understand. But I want to make sure you guys know how to multiply things by its conjugate. So the conjugate would be 3 plus radical 3, and this would be 3 plus radical 3. And here's the cool news about this. Basically, the denominator just becomes 3 times 3, which is 9, minus a 3, it becomes a 6. Because this radical 3 times this radical 3 becomes 3. And the things in the middle, because of the FOIL method, cancel it out. So you just get a 6. The numerator, on the other hand, using the FOIL method, you get 3 times 3, which is 9. You get a 3 radical 3 and another 3 radical 3, which will get you a 6 radical 3. And then radical 3 times radical 3 is just 3. So you end up getting 12 plus 6 radical 3. And 6 goes into both of them, so the final answer is 2 plus radical 3. So that's actually the best answer, which they don't have listed, but that would be the best answer. And all I'm going to do is I want you guys to see that they actually mean the same thing, and then I will submit my answer. 3 plus radical 3 over 3 minus radical 3. Here we go. 3 plus radical 3 over 3 minus radical 3. There's the decimal. I want you to see that it's the exact same thing as 2 plus radical 3. So, this is the answer you're going to choose for the Khan Academy, but this would be the best or the most simplified answer, being that we don't want to have irrational numbers in the denominator. It's considered a big no-no. Okay, so there's our answer right there. You can see it right here, and you're good to go. Okay. Hope this video was helpful. The main thing you're going to need to make sure you know is how to get what? Use the 45-45-90 and the 30-60-90 triangle, because that helps you with all. You'll notice we used it all the way through out. Either we're using a 45 or a 30-degree angle all the way throughout the whole lesson. Okay? So, hope this was helpful, and you guys make sure you guys write down all of your identities and use those step by step. Have a good day.